The motivation for looking at meteorite impact craters is if you stand up and look at the moon on a clear night, even without binoculars, you can see that the moon is pockmarked by impact craters. NASA is, with the other world space agencies, are really formulating how we're going to train astronauts in the lead up to the Artemis missions and the return to the moon.
That's Dr. Gordon Osinsky. Canada's own Dr. Oz is a geologist, professor of earth sciences, research chair in earth and space exploration at the University of Western Ontario, and an RCGS fellow. He's also our guest on this episode of Explore, a Canadian Geographic podcast. Welcome to all you explorers out there, armchair and in motion. This episode has a little bit of everything in it. Giant remote Canadian meteor craters, space rocks, astronauts, and moon bases. But before we get to our own Dr. Oz, a reminder that by donating to the Royal Canadian Geographical Society, you're helping to support educational programming, expedition funding, research grants, and many other society-funded geographical initiatives, helping the RCGS to carry out its mandate of making Canada better known to Canadians and the world. So to make your tax-deductible pledge, please visit rcgs.org/donate. And thank you. And now, on to Dr. Oz. Dr. Gordon Osinsky, welcome to the Explore podcast.
It's a pleasure to be here.
Well, it's great to have you here. And the expedition you went on sort of ticks a bunch of boxes of what we love on this podcast. It's a remote and very interesting location in Canada. You've got a couple of astronauts with you on this expedition. We love astronauts on the podcast. And I have to add, too, that you're helping us correct a glaring omission on the pod. The Royal Canadian Geographical Society was founded by Charles Kamsel, who was one of Canada's leading geologists in the day. And we've never had a geologist on the podcast, so thank you for correcting that as well.
Oh, wow. Well, I'm glad I can set the trend, and hopefully there'll be many more.
Hopefully there will be many more. So tell us about this expedition with these two astronauts, where you went, first of all, and what was the interest in that place?
Yeah, so last September, I headed up to what is known in English as the Kamestastin Lake impact structure, or in the local kind of Innu dialect is Kamestastin. And so this is a roughly circular lake, a couple of 100 kilometers to the north of Happy Valley Goose Bay, so kind of in north central Labrador. And our reason for going there is that this is a meteorite impact crater, and a very special one. So that was the major motivation to head up there in September.
Yeah, and so the two astronauts that are with you, who are they, and why are they joining you on this trip?
Yeah, so first and foremost, this was an expedition that I was heading up with some students, to conduct research. And at the same time, I was also, lucky enough but offered up to NASA and the Canadian Space Agency to take along a couple of astronauts. So Joshua Kutrick, who was one of the last two selected Canadian astronauts, and then Matthew Dominic was in the same class as Josh, actually, the Turtles as they're known, and they both became astronauts about 2 or 3 years ago now.
So tell us about the lake and what makes it special. Why were you guys there?
Yeah, so obviously, the motivation for looking at meteorite impact craters is, if you stand up and look at the moon on a clear night, even without binoculars, you can see that the moon is pockmarked by impact craters. And so unlike on Earth, where, there's lots of other geological processes that come to bear, the surface of the moon is really shaped by two main geological processes: volcanism, but that ended about 3 billion years ago, and then impact cratering. So essentially the impact of asteroids or comets with the surface of the moon. And, that means essentially that, everywhere we go on the moon, you'll be running into meteorite impact craters. All the samples that we bring back have been affected by at least one meteorite impact event. And so really anything we're going to do on the moon and anything you want to do to understand the moon, you really need a good understanding of what we call the impact process. And it turns out here in Canada, we have, a large number of impact craters, 31 to be exact. It's actually what brought me to Canada over 20 years ago to do my PhD. I was working on another crater in the far north. But this crater in Labrador is unique for many reasons. It's relatively well preserved. It formed about 35 million years ago, which to the non-geologist might, seem like forever. on a long, long time
Yeah.
ago. But in terms of geology, and when the age of the Earth is 4.5 billion years old, 35 million years is actually fairly recent in geological terms.
So that's not a wiping out the dinosaurs one. That's a
No,
more recent
no.
one. Yeah.
So the size of it is about 28 kilometers across. So it's
Hmm.
about a tenth the size of the one that wiped out the dinosaurs, which means that, if you were unlucky enough to be there, 35 million years ago, it would have had some pretty significant consequences across Canada, but it wasn't global in its environmental impacts.
What would be the impact of that been, just out of interest?
It's a great question. And so a quick sidestep, in studying impacts, it's a good and a bad thing that we haven't witnessed a large one in our human lifetimes, or in human
Hmm.
history. So, unlike volcanism, where, if you're looking at ancient volcanism on Earth, you can go and study the process today, right?
Hmm.
Somewhere on Earth at any one time, there's a volcano erupting. So you get to witness the process happening. Whereas with impacts, again, thankfully, we haven't witnessed the process happening. So it means we're reliant on, experiments, doing geology, and ancient rocks, numerical modeling, and perhaps our kind of best understanding of the environmental impacts in particular comes from the nuclear tests of the 1960s and 70s, where,
Interesting.
I don't think many of us would agree that it was a good thing, but, they calibrated, they put a lot of instrumentation out in some of those big tests down in Nevada in particular. And so, they measured how hot the surface got, where the fireball went, and that kind of thing. And so, you know, Labrador, this crater would have formed. We would have had, a ejector going out and, really erasing the surface for, a few hundred kilometers.
Wow.
But by the time you get, down to where I am in southern Ontario now, you would have had, particulates in the atmosphere and maybe the odd thing landing. It would have caused, short-term climate change for sure. We know even after a large volcanic eruption that, you can get slightly cooler conditions and things across the world
Hmm.
because, once stuff's lofted into the high atmosphere, it can circulate. But, to our knowledge, no mass extinction, nothing like that.
Huh. Fascinating. So the interest for you then is the crater itself to some degree, and is it also the rocks that you're finding there? Or?
Yeah, so the crater is actually quite unique. So, because it's relatively well preserved, it's also relatively well exposed up in the tundra of northern Labrador. So, there's some craters in Ontario that are buried under forests and swamp and things where you just, you can't really see anything. So there's those two aspects, which means there's a lot of the rocks produced by the impact that you can go and walk around, study, investigate, and sample, and some spectacular, cliffs, tens of meters high of rocks that were molten by the impact. So really quite unique. But what
Ah, yeah.
really gives this crater, a leg up on almost any other crater on Earth, is that it also formed into a large part in a rock we call a northocite. And so a northocite, think of a granite that you might have on your kitchen counter, or you might have encountered wandering around the
Hmm.
Canadian Shield, or various parts of Canada. If you take
Hmm.
away the quartz and the pink mineral in there, the potassium feldspar, you're left with a rock that is dominated by plagioclase feldspar. And so it's kind of 90% this one mineral. And it turns out that that is what the lunar highlands are made out of. So when you
Ah,
look at the moon, all of the white stuff that is, that dominates the surface of the moon is a rock, is this same rock, a northocite. And so here, we have a relatively young crater in Labrador, relatively well preserved, and it formed in essentially the same rock type. And there's really only one or two other craters in the world where we have a substantial portion of a northocite, but again, they're not as well exposed and preserved. And so, we can go up there and see what we call ejecta deposits, that material that is thrown out, broken up, and redeposited by the impact event, and it's made up of a northocite. And so, this is what we think the astronauts will encounter when they go back to the moon. This is what we want them to be looking for when we go back to the moon. And so this is an ideal training ground. And, there's some really cutting edge science to still be done at this crater too.
so You've got these two astronauts with you, Joshua Kutrick and Matthew Dominic. What are you? So are you training them to be geologists in effect when you're up in this crater? What's going on?
Yeah, I think, pretty put simply, that's what we're trying to do. I would say that this trip too was a bit of a reconnaissance. So NASA is, with the other world space agencies, are really formulating how we're going to train astronauts in the lead up to the Artemis missions and the return to the moon. We did
Mm-hmm.
it during Apollo. It's maybe a little known fact that in the lead up to all of the Apollo missions, those astronauts were getting a huge amount of geology training, particularly during the last three, which were these so-called J-class missions, where science was really, they'd been to the moon three times.
Mm-hmm.
The last three were really science-driven. And so, they were actually spending, on average, about a week, a month in the lead up to those missions doing geology training. And so, part of it is just getting some basic geology skills because, this was just a random coincidence that basically Joshua and Matt are fighter pilots. So they trained as pilots, their military upbringing. So, they really haven't had much geology training in the past, just like the Apollo astronauts. So, part of it is, just learning the lingo. We unfortunately have a lot of that in geology, certain rock types, names we give to things. But I'd say even more importantly is just the process of how you go about exploring an area, documenting, outcrops, documenting where you collect samples, because, they are our remote geologists on the moon. Most, just about all the science will be done on the samples that they return to Earth. And so, having them just understand the process of how about you do geology is absolutely critical so that, when they bring the samples back, we know where they came from, what the context was, et cetera, et cetera.
I want to talk about Artemis a bit more, but can you just tell us a bit about the Kamestastin Lake itself? Like how did you get there? How remote is this?
Yeah, so compared to some of the other craters I've worked at in the far north up in Nunavut, it's relatively easy to get there, and I say relatively.
Yeah.
You're a commercial flight into Happy Valley Goose Bay, where there are grocery stores and a hardware store that I don't get in the far north in the tiny little communities. And then we basically charter a Twin Otter aircraft and take about an hour and a half, hour and 45-minute flight, just not quite due north. It's actually quite close to the Quebec border is this lake up in as
Mm-hmm.
Labrador kind of narrows. So
It's sort of up at that parallel with Hudson's Bay, isn't it? Just to give
yeah,
people an
yeah,
idea.
yeah,
It's
yeah,
it's
mid
that sort of
50s degree
yeah.
latitude.
Yeah.
So you can obviously take a float plane anywhere in the north and land it because it's
Mm-hmm.
quite a big lake. But we're actually quite lucky in that there's a good airstrip on some nice flat old gravel terraces, and it's actually quite remarkable. Even since the last time that I was up there, which was over a decade, the Innu actually have a hunting camp on the shore of the lake because it used to be anyway a good caribou hunting region, and there's great fishing in the lake. So there's actually quite a good, again by northern standards, kind of gravel airstrip with just a few bushes. And so
Mm-hmm.
we, land the Twin Otter, take a couple of flights to get all of our gear in, and then we, set up a remote base camp. And then from there, it's, exploring the area by land on foot. And
Mm-hmm.
then the lake, gets in the way sometimes, but it also means that we can use a Zodiac boat to get around it, fairly quickly.
Mm-hmm.
So, the lake itself is about 16 kilometers across with an island in the middle. Quite a prominent
Wow.
island, which is actually part of the crater formation that we want to explore.
Is that in the north of Side Island then, is it? Or
It is, yeah, yeah. Part of the island is a northocite, and we call this the
yeah.
central uplift. So these are rocks that are actually brought from about 2 kilometers down to the surface in less than 5 seconds.
The
Such is
impact.
the energy of the impact, and so that was one of the sites we wanted to visit, and then lots of really neat locations around the shore of the lake as well.
Amazing. And in terms of just the terrain, is it black spruce forest or what are we looking at around?
You're right, kind of in the transition to true tundra. So
Hmm.
in some
Wow.
areas, when you get up onto the plateau around the crater rim, it's pretty barren and windswept, and you've just got
Hmm.
some low kind of vegetation. But in a lot of the valleys where it's a bit more sheltered, you have the black spruce and things too. So it's a really neat mix of vegetation up there too.
Yeah. And how did your astronauts do as geologists?
I mean, they really did excellent.
Yeah.
They unsurprisingly, because they
Yeah.
were selected out of thousands of people to become astronauts, they're incredibly fast learners. They pick things up so quickly. They ask great questions, and yeah, by the end of the trip, and this was a relatively short trip of about we had actually kind of 10 days on the ground at the
Yeah.
crater. They were not quite going out on their own, but we would work somewhat independently, over a few hundred meters, and they were making some great observations. They found a
Hmm.
couple of things that we told them, watch out for this, and they came running with smiles on their face, saying, "Is this what you were looking for?" So it was really fun, and yeah, just really good to see them learn and apply things over the course of a few days.
Yeah. No black flies and mosquitoes on the moon, though.
No,
I'm guessing.
they got other challenges, but no bugs. So yeah,
No
that's a
bugs. Yeah. How
positive.
are the bugs up there, though?
They weren't too bad. I timed it in September. Very
Yeah.
late August into September, so that they had died down a bit. It was quite warm and calm when we landed. The first couple of days there were a good number of bugs that were driving
Hmm.
people crazy, but then middle of the trip it snowed actually, so we had a couple of nights below zero, so
Yeah.
that
That
made for
helps. Yeah.
a different kind of challenge to do geology and field work, but it did get rid of the bugs at least.
Yeah, for sure. And so I'd like to talk a bit more about Artemis. It's this NASA mission to go back to the moon, first time obviously since the Apollo missions. A lot's changed, I guess, in that time. I'm sure in geology as well as in space travel. I mean, what's going to be different about how they go about or what they're even looking for on these next missions?
Yeah, so in terms of the infrastructure and getting there, of course, they've had to completely, come up with a new modern rocket, capsule, everything. So everything in terms of the infrastructure, the engineering has essentially been, not quite designed from scratch. Lessons
Hmm.
learned from Apollo and Shuttle. But it's interesting, right, that we're going back for this, and I think into the future, with more of the Apollo era, standing rockets. So not like the shuttle, a sort of plane-like spacecraft. But as SpaceX have shown, we've come a long way in terms of reusability of, the rockets and things too. So, a lot of, again, almost starting from scratch in terms of the infrastructure. So that's coming along. There are delays like with anything, and of course COVID
Mm.
didn't help too. But
Yeah.
we're seeing demonstrations of all the various bits and pieces, and hopefully later this year we'll see Artemis 1, which is going to be an uncrewed test of, so SLS is the Space Launch System, the rocket,
Hmm.
and Orion is the capsule where the people sit. And so hopefully by the end of this year we'll see, because it's been delayed from last year, the launch of this to test out everything all together. And then there'll be an Apollo 8 like flyby, Artemis 2, which is exciting for Canada because they haven't announced the names yet, but that spacecraft will fly to the moon, around it a few times, and then come back to the Earth. And so that will have 4 astronauts on board. And then, yes, they've announced that one of those 4 will be a Canadian astronaut, which will just be absolutely amazing. And, for the first time since Apollo, we'll have, a person, seeing moonrise, Earthrise, flying around the limb of the moon and peering back at Earth. And so that's going to be, just simply amazing. And then hopefully,
Yeah.
after not too long after that, a landing. So to get to the science, quite a bit has changed. And so, one of the major, I'd say, some people would say the most, but one of the biggest scientific discoveries made since Apollo in terms of the moon is that it's not completely dry, which is what we suspected 50 years ago. So we know that there are volatiles on the moon, water ice in particular. So a couple of different types. We know that the moon is not quite as dry internally because actually some of the samples retrieved from the moon brought back by the Apollo astronauts, these little glassy beads were erupted from volcanoes, and they contain minute amounts of H2O. What we're going for initially, though, and why they're targeting the South Polar region, is because we've discovered that there are craters there, impact craters near the pole, that are essentially permanently in shadow, and so we're talking billions of years where the sun has never shone. And so that means over the billions of years, very tiny concentrations of volatiles have ever so slowly built up. And so, we've seen from orbiters what we think is water ice in some of these regions. And so the science is being driven by volatiles initially, to go to the South Polar region, with the first Artemis mission and maybe the couple after that.
Why is finding water on the moon important?
So as a scientist, it's incredibly important to, interesting. How did it get there? Why is it there? How does it survive so long? There's lots of scientific questions. But, absolutely the motivation is because if we can find that water, we can use it and extract it. And there's this kind of buzzword ISRU that is floating around the community right now. And that stands for in situ resource utilization. What it basically means is that we could live off the land. Space travel is expensive because, every kilo that you launch from Earth comes at a huge cost. So if you can reduce, and the biggest cost is just to get to low Earth orbit. If you can reduce the mass that you have to launch off the surface of the Earth, then it will reduce the cost of space travel, and it will just open up so many doors. And so the goal is that we can find water, excuse me, and then use it in the short term, for people to drink, to extract the oxygen to breathe, and then also, in the medium term, rocket fuel, so that you could actually refuel the rocket to get back to Earth, or use it, as essentially, a moon gas station where, you can fill up and then go onto Mars or beyond as well. And so it's really quite exciting to think that, we might be able to find and use the resources in a sustainable, and fashion on the surface of the moon someday.
Would that include a moon base then at some point? Was that part of that thinking?
So it is definitely being talked about. I hope it actually happens this time. The model would be something like Antarctica, right, where we set up an outpost and that there are people there. I think it will morph like Antarctica has, where initially we went there for science, a century ago, but there was a lot of other reasons too, geopolitical and just to explore the region. But hopefully we will see, and all the world's space agencies are talking about it. So I think it's just a question of when, not in the next decade, absolutely. But, I think slowly but surely we'll start to set up some infrastructure and see people there for longer missions. And then, maybe eventually it'll be like the space station where 24/7, 365 days a year, there's, a permanent human presence on the moon.
It's fascinating. We had Canadian astronaut Roberta Bonder on the podcast, and she said she thought that was the next important thing that happened, was actually a moon base gets built. And part of the reasons too are geopolitical. She thought, like, who owns space or who owns the moon? And we need to figure these things out, and this is how to do it.
Yeah, absolutely. Yeah, no, there's lots of, one of the I find fascinating aspects is we're having to redo some of the existing laws for outer space and come up with new ones, especially when you get to extracting something, right? Who owns it, who can do what with it, what can you build where, etc., etc.
Was there anything that surprised you about working with the astronauts on this trip? Was there any moments that sort of stood out?
So I did actually have the opportunity to work with Josh and Matt during their basic training, or not so basic training. So, all of the astronauts go through a pretty grueling 2-year process that when they have to, pass a whole series of tests and things to qualify as astronauts. And so that's after they've been initially selected. And so, they had some basic geology training during those 2 years. I was down in the classroom with them, and then in northern Arizona with them in the field for a few days as well. And so, I got to know them a little bit, got to see them in action. And I don't think I was really surprised too much. They, in addition to the science, right, they chipped in with everything. You're running a camp in a remote location. The conditions are pretty harsh at times. We had, after it got cooler, some wet weather. We were crossing rivers, with snow in the air, and but they just, jumped right in, as I think most of us would do and did do in those situations, and ferried other people across the river, and we had to fix the Zodiac one time, and we're getting crashed over by freezing cold waves and things, and they stood their ground, contributed, kept smiling, and I think that's why they were selected to be astronauts in the first place too. Yeah. That's the kind of people we need, right, to go out into space.
Yeah. One of the last astronauts on the moon was Harrison Schmitt, who was a geologist. Are we due for another geologist up there? And are you in the running, perhaps?
Well, I don't think I'm in the running. Maybe getting a bit long in the tooth, and I'm actually more than happy to, be participating in the training of the astronauts who will go there. I've met Jack Schmitt a few times, and I was just at a conference last week, a virtual one, and he was there still talking about and as excited about, lunar geology as he was 50 years ago, which is quite remarkable. I think he is a testament to demonstrating why having someone with a lot of geology experience does make sense as well. And so, I think it will be a mix. I'm actually quite excited right now up on the International Space Station. One of Matt and Josh's teammates who they graduated with is Jessica Watkins. And so, she's already broken a few records in doing what she's doing. But she was actually a Mars scientist. And so she, got her PhD, was working on one of the Mars missions when she got selected to become an astronaut. So, there are a few other geoscientists in the astronaut corps, but she's one example of, the new recently graduated astronauts that does have that geology training. And so, yeah, I hope it will be, a mix of trained geologists, engineers, doctors, right? We need all expertises in everyone. And, of course, absolutely always need the pilots. And so there's always a place for them too.
Someone's got to get you there. Yeah.
Yeah.
Well, listen, thank you so much for your time. This is a fascinating discussion. I have a question I ask all my guests, and you've certainly traveled this country to very remote places, but what is your favorite place in Canada, a place that you maybe really sticks in your mind or that you love to go to on a regular basis, or maybe just a happy place?
Oh geez, that's an incredibly hard question that you maybe should have forewarned me on. There's some places closer to home where I enjoy going with my family, canoe tripping and things with my kids and wife.
Give me one of those.
You can't beat Killarney and Algonquin Park in Ontario. In terms of I think probably my favorite place is Devon Island in the Canadian High Arctic. I'm lucky enough to be going back there again after a bit of a hiatus this summer. It's an out of this kind of world environment. It's a polar desert, remote. It's the largest uninhabited island on Earth, and just not a speck of vegetation. So barren but beautiful, a true wilderness. And again, it's definitely one of the places that I enjoy going back to time and again for research predominantly, but it's just an amazing place to be, period.
Fantastic. Well, Oz, thank you so much for coming on the Explore podcast.
You're very welcome, David, and it's we're happy to come on again in the future.
Yeah, we look forward to updates on all of this. And thank you for listening. Thanks as well to everyone who has given this podcast a 5-star rating and written flattering reviews. The more positive feedback we give the algorithm, the wider the audience we can reach with this interviews. It's really appreciated on our part. And don't forget to subscribe so you don't miss future episodes. And speaking of a wider audience, while it's very gratifying certainly to be on podcast charts here in Canada, I want to give a shout out to our listeners in Portugal, Belgium, Ireland, and South Korea who have us charting over there. We see you and we thank you. Merci. Miigwech. And so until next time when we'll explore again, I'm David McGuffin.
I think right now we're enjoying very much looking back at the Earth, and it's just a fantastic experience, and I just can't wait to get back and start telling people
We left
about it.
Simpson about June 10th with the fur brigade, consisting of a number of yacht boats, each manned by 10 voyageurs.
For us Inuit, it means that Inuit oral history is very strong.
And we flew low over every inch of the country that could be. We were hoping that he would fire at us.
I guess 160 dives or so. There are shrimp, fish swimming around outside. It's just fabulous here.
Well, I'm a first for Canada.